Good day. Today we're going to be looking at these Raspberry Pis here, and we're going to be looking at how they do when it comes to heating up under heavy stress. So we're going to be running some benchmarks on them. Now the benchmark is going to be a 10-minute test, and we're going to start it at an idle temp, and usually around 38 degrees is where we're going to start, and then we'll see where it ends up at the end of the test and kind of a ballpark of how long it takes to cool down. So when it's cooling down, what we want to know is, will it cool down to the idle temperatures it once was at, or if it's going to stay somewhere up in the clouds where it doesn't belong. That way we can kind of see ultimately which case is the best case. So I'm going to be running this in VLC Media Player, just because it makes it easier. That way I don't have to unhook everything and we can get through this fairly quickly. So the one we're looking at right here is the 3D printed case, and what we're going to do is we're just going to kind of see what happens here at the beginning. I'm going to skip to the end and then I'll show the cool down of the unit. Okay, so I'm just going to go ahead. I'm going to start that. All the code for this is posted in the description below. You're going to be able to run this on your own Raspberry Pi, get your temperatures, and I'd be curious, post your results down below as well and let me know how you made out. So I'm going to press play here and we're going to start this. So all I'm going to look at is probably the first 2 or 3 results here. That kind of gives us our base point. So now we have a 38.4 start. Our first substantial jump is over 10 degrees Celsius here, and then we're going to start to rise up from here. Now let's scroll to the end here and we will check out what the final is. So at the end of it all, we are sitting at roughly about 64.7 degrees Celsius. We're just going to wait here just a second here and see if we get any higher, and it doesn't look like it there. So in the 10-minute test, we did get those temperatures getting up to as high as 64.7, and this is on that 3D printed case here. So that's not bad. I'm okay with that for my first run. But what I'm going to do here is I'm just going to go, was that 1017? So let's see how long it took to actually, this should be the right file. So it took about 3 minutes to drop back down to about 36.5 degrees Celsius, which really isn't that bad as for an idle temperature. So I'm okay with that. Getting back down into the 30s is great. Over time, had I left it, I'm sure it would cool down even more. So now we've gotten that guy tested. What we'll do here is we will go ahead and we will test out this guy here. Now, if you haven't guessed it, I'm a big fan of cheap cases. And if I wasn't given the argon one from the contest that I randomly won it in, I probably wouldn't be using it on my test here today. But with that being said, I'm not paid, sponsored by anyone on the bench here. This is just me messing about. So let's have a look at this guy here, and we'll see how well this does. Now I do like that this case has some actual cooling venting holes on the bottom here as well as the top. That's one thing that my design did not have, which maybe we'll incorporate into a future design. But let's go ahead, let's bring up those results here. So I'm going to go ahead, I'm going to load that one up here now. Okay, so we're going to run the test here. We're going to start once again at that 38.4 degrees Celsius, and let's see where we jumped up to here. So once again, another 10-degree jump, and I'll wait for one more here, and then we will bump over to the end here. So on the third one, we're about 50 degrees. So let's go ahead. I'm going to scroll on down, and we'll stop it around right around there. So, and I'm going to just stop it because this is where the test ends, and this is where we're going to see our final temperature here at 71.1 degrees Celsius at the highest point of this 10-minute test. It's pretty high in my books. I don't know about you, but for a case that you purchased, it shouldn't be that bad in my opinion. Now there could be a few things that are going on here, but with that being said, maybe we'll investigate that later and see what we can do to each case to make it a better case. Took about 4 minutes to get itself back down to around that 42 degrees Celsius, 40, to 44. So 4 minutes to cool down to that, and it really wasn't dropping any lower than that. Like, there's more screen above where you don't see of it actually taking more time than that to fully cool down. So from 70 to 44, I'll call that a win. Still not my favorite numbers to see, but you know what, that means we just need to move on to the next guy, which is going to be the Argon 1. Now with its metal design, like right now to the touch, it's cold, it's turned off right now, but it is a cold running unit. So what I'm going to do is I'm going to get that video going one more time here, well, a couple more times here, and we'll see what happens here. So I'm just going to go ahead and get that code running here. And so we're starting at about 33, 34 degrees when we first launched this. So that argon case is keeping pretty cool in my books. That's not bad. So first one here, only a 6-degree jump. That is 4 degrees better. Well, I guess yeah, it's any way you shake a stick at it, it's definitely a lot lower of a jump than the other two cases so far. So that is definitely in its favor. But now I'm going to scroll to the end, and we're going to see something pretty interesting here. So as I'm scrolling here from around the 8-minute mark here, and I'm going to use that as an example, to the end here, we don't see we see it kind of just hanging out in the high 50s, and that's completely normal. And right there, that is the highest temperature that we get. It's 59.9. This is great. This is probably the best one so far that has kept that high temperature really low. But now, with that being said, now we haven't hit that 60 degrees Celsius mark. We might have on that 15-minute run for sure, but we didn't, so that's good on the 10 minutes. So what I'm going to do is I'm going to bring up the picture for how long it took to finally cool down here. Almost 10 minutes later, we're finally seeing it cool down to about 44.3 degrees. Now on the Argon 1, I do have the fans to always on. All the other units are doing that as well. They're constantly on. There's no there's no actual controller on any of the other units, so no sense in doing that if well, they can't actually cool themselves. Cooling down time is pretty ugly, and I'm not too happy about that for a case that costs as much as it does. Then again, this is a case that I use for my daily Raspberry Pi routine, and it does that. It just acts as a day-to-day driver for web page surfing, email, YouTube videos, Netflix, all that kind of stuff. I'm not doing anything really heavy on it, so it's actually a good unit for that. But if I was to use anything else on it, I wouldn't really want to go that far with it, because it is a unit that keeps that heat and takes quite a while to actually dissipate. So now that we have finished those 3 cases, so let's go ahead and check out the final guy here, and that's this guy here. And this is my $2 Raspberry Pi 3 case that I got on sale, and I just hacked it up and I added a fan from a Nintendo GameCube or a Dreamcast or a Nintendo Wii. I can't remember which one, but they're really good fans. I always love the output of the video game system fans, and they're usually these 5-blade fans, and there's a reason for it, because they actually move a lot of air. So let's have a look at our results on that. So I'm going to go ahead, I'm going to load up that video here. Alright, so it should be playing now. So we're starting at that 38.9 degrees Celsius temperature. Doesn't surprise me. That's been kind of the regular along the way. And then we do jump up that 10 degrees that we've seen before in the previous one. So the argon 1 definitely has the initial heat up temperatures a lot smoother than that of the plastic cases. So I'm going to go ahead now, I'm going to scroll to the end here, and we're going to have a look at what our final results are. Okay, so we have completed our test, and what do you know? 56.9 degrees Celsius is our highest temperature throughout the entire process. Now, that's pretty good in my books. Now, the Raspberry Pi, like with a couple dollars worth of parts, and this is where I had that issue with purchasing any case, is because these were the results I was getting before, and it's hard to tell someone like, no, I don't want that case, because, you know, my case here is absolutely fine. Like it does the trick. So when something as simple as that produces that kind of a result, I'm quite happy, and at that point I don't really care about the look of it, because I'm keeping it under that of a metal expensive case or any other case with you know, see, even this case here, I think it's a 7-blade, and this one here I do believe is a 7-blade as well. Yeah, so these are all 7. This one here, and I do believe it's a 7-blade in here as well, are all losing to the power of this little 5-blade fan. So yeah, for me it's hard to justify purchasing a case when a couple dollars will do the trick. So now, playing with the 3D printed stuff, that's kind of where I'm at, because now I can actually try to make something that is going to work for me and make it at a fraction of the price, and then get those results out. Now, yeah, sure, this thing looks a little janky, but you know what? It was fun to play around with and get some results. Heck, it did even better than this guy in the overall top temperatures, and it also beat out the argon 1 in the cooling down process. So all in all, not the worst case on the bench. But this guy here, we're going to have a look at the cool down process now. So here we go. This is that kind of proof that I was trying to represent in a fashion that this is what I'm getting. Why would I purchase something that's going to be not as good? So at 9:40, it was 1 minute and 10 seconds later, I'm down to 33.6 degrees or whatever it is, 30, just under 34 degrees. And how can you beat those numbers? You can't. So in 1 minute, it's not 4 minutes, it's not 10 minutes, it's right away. There you have it. The actual winner of this was not my 3D printed case, was not the argon one, or that other thing we'll pretend is the case. It was this guy. Could it be the fan that's on here? It could be. Honestly, I don't know. I would love to try a few other fans on this, as most of these all ran the same Raspberry Pi setup in it as far as the heat sinks on the unit, except for the argon one, because only 2 of them I could keep on it, and I had to remove the rest so it could mount onto its case. But this one here is definitely the one that I'm going to have to look at more into, as well as playing around with this guy here. Now, as you can see here, we have a filter on here, and that's just because when you use these as a desktop, they do tend to get dirty. And as you can see, there's another fan in there. So these are 40 millimeter fans as well. And I do believe that 5 blade is a 30 mil. So I'm going to get some more 30 mils, and maybe I'm going to design up something a little bit different for my desktop unit, as well as maybe an add-on for the Argon 1 to help promote some more cooldown, as it is a great unit, but with anything, it can be flawed. Except for a hacked up Raspberry Pi 3 case, which works wonderfully. So there you go. There's the winner. I hope you enjoyed this video, everyone. Leave any comments below. In the description below, you will find the link to setting up the benchmark yourself. Give yours a test and let me know your results below. Let me know any questions or comments. Make sure to subscribe, hit that like button. Thank you for watching, everyone. Have a wonderful day, a wonderful week, and we'll see you next time. Take care, eh?